Thank you. So, vanadium. So today we're going to cover off vanadium, a bit of a market overview of where the status quo is at the moment, and maybe gaze a bit into the crystal ball of where it could potentially end up if it does take off as a battery mineral, which a lot of people are projecting it will. So just a brief overview of where we're going to be heading, look at the present drivers, the historic production, demand and prices, the sources of vanadium, which is quite an important part of the story, a regional breakdown and what the constraints and risks involved with those sources, the changing marketplace, as we say, energy storage, and could this lead to supply gap, and then what do we need to do to fill that supply gap. First of all, what are the uses of vanadium? It's primarily used in steel. The vanadium story up until today has largely been a steel story. Its properties involve imparting high strength as an alloy into steel. It also has corrosion and oxidation effects. A very little vanadium has a big impact on steel in terms of strength. It's also used as an irreplaceable role in the aerospace industry. Vanadium-titanium alloys is one of the strongest materials that we've developed for strength for weight ratios that's out there. And also in aluminium in jet engines and aircraft mechanics, it's a very indispensable element as well. Cannot be substituted for. The non-metallurgical applications are a relatively minor part, but it includes things like catalysts, ceramics, electronics, specialist vanadium chemicals, and where we're going to be ending up today, it's becoming increasingly used in green technology. The influence of what market projections are for the vanadium Redox flow battery and what potential impact that could have on vanadium markets as we go forward with the projected renewable energy targets that are being set around the world. Vanadium-Source. Primarily the Vanadium-Source, it's magnetite iron ore. So vanadium, titanium, magnetite deposits hosted in large igneous complexes, and some large complexes do dominate world supply, particularly Sichuan province in China, the Bushveld complex in South Africa, various complexes in Russia and Canada. Vanadium is also produced as a byproduct of fossil fuels, from processing the fossil fuels, burning them, particularly in energy consumption, and also cathodes. You produce vanadium in the ash residue, so the processing of that. Petroleum in Venezuela is a particularly important source, same as oil sands in Canada and the US. Coal in China, Europe and the USA as well. From burning of coal to residue ashes, you do concentrate vanadium in the ash. Vanadium is also a byproduct of uranium production. So charnakite, the uranium mineral, contains a substantial amount of vanadium in its mineral lattice. So as a byproduct of uranium production, you do produce vanadium. The present supply of vanadium, well, as I said, it's largely dominated by co-production in the steel market. So magnetite ores, 71% of magnetite production, or 71% of vanadium, I should say, comes from the processing of magnetite ores as a co-product. The secondary production covers the various other things such as the uranium and the petroleum industry. It's only about 17% of the supply out there is a primary vanadium resource. Everything else comes as a byproduct of other elements. Production total, well, you can see that China actually dominates production, and that's largely through their steel industry and domestic supply of their own magnetite iron ore into their steel industry. They produce vanadium as a byproduct of that. The next biggest heavyweights in that market are also Russia and South Africa from their various large igneous complexes, particularly the Bushveld complex in South Africa. So China dominates the production. When we look at the present supply constraints, there's been a few things that's happened recently that's impacted that supply. Biggest driver has been in China, where we've had crackdown on importation of various slag materials into China. It's now been legislated against, so where they used to source a lot of second-hand vanadium from other people's slag and byproducts, they no longer do that. Also, there's been a crackdown on mining in particular areas in China, and also in steel production, high-polluting steel production. So these have had an impact on the Chinese market. In South Africa, we had shutdowns in the Bushveld complex of various producers that negatively impact their production quite significantly. And also in North America, with the petroleum industry there and importation embargoes of Venezuelan oil, we have less vanadium being produced in the USA, in their domestic market, from the processing of that Venezuelan oil. And even though we've had a significant increase from a major player in Brazil in Largo Resources, we still have a net deficit of, well, a net decrease, I should say, from 2014 to 2017 production of 6.5%. present consumption of vanadium, well, as I said, it's a steel story, primarily. So if we look at between 2015 and 2017, not a lot of change in terms of the market dynamics. It's been dominated by steel. We see, particularly with, as we get into it a bit further, legislated changes in the Chinese steel industry with the requirements that they have to produce higher strength steel alloys and rebars, has increased the high strength, low alloy steel market in China, and that in turn increased the consumption to 76%. But as we see at the top of the thing there, the battery market at the moment is still a relatively minor player in the vanadium story. 1% in 2015, 2% in 2017. We'll have a look in a minute at how that might potentially change into the future. Where the present consumption is going, it's a pretty busy slide, but the main thing to take away from this is this orange bar here. So even though China is the largest producer of vanadium, it's also by far the largest consumer of vanadium as well. So with any crackdowns on the mining industry in China, where they're no longer able to produce to meet their own demand, that could have a major impact on markets going ahead. And when we look at how specifically vanadium consumption varies from country to country and region to region, we see that if we, let's go back. If we look at what the world average is of consumption of vanadium and steel, in the Asian markets of China and India, we still have fairly significant room to move just to meet that world average of vanadium use in steel. If we look at what the European and USA uses are, there's a substantial room for move in these markets to be able to bring their steel industries up to the same specifications and standards as the steel that's been produced in Europe and the USA in terms of vanadium use. The present market has largely been dominated, and we'll get onto the vanadium price shortly, by the unfortunate event of the post-2008 Sichuan earthquake in in China, where something like 68,000 people perished. And that was primarily blamed on poor building standards. So they had a major move in China to bring in compulsory rebar standards for steel and compulsory vanadium content of rebar. And this has been a huge driver in the markets of vanadium recently. In February 2008, they reinforced those standards and brought in compliance measures and enforcement measures. And that's going to be coming into force in about November, but it's already having a substantial impact on the vanadium price. So if we look at the vanadium price and how it's been moving, you see vanadium supply constraints here, where Russia's vanadium disappeared from the market, the advent of grade 3 rebar standards in China in early 2005, problems with supply in South Africa because of their power issues, having major spikes, and where we currently stand at the moment, and this is where we see the influence of those Chinese rebar standards coming into the vanadium price. And in fact, before we even start talking about vanadium as an energy mineral, vanadium is already the best performing energy mineral in the last year. So just based purely on the steel story, we've had 120 to 130% increase in the vanadium price in the past 12 months. What's going to impact on that when we start actually talking about it as an energy mineral? The projected global energy generation market, this is based on various targets that have been set by various countries around the world. By 2050, between 50 and 100% of energy production from renewable sources. There's this part of the graph here, solar and various wind energy capacity generation by 2050, significantly overtaking the historical markets of fossil fuels. One of the big problems with the renewable sector, though, is energy storage and being able to use that energy in times of peak demand. Vanadium redox flow batteries is one of the technologies that's being taken very seriously at the moment to meet that market of energy storage. One of the advantages of vanadium redox flow batteries over others, if we go back, significant long lifespans. Able to completely 100% discharge and recharge without any ill effects. Safe. There's no risk of fire with these styles of batteries because they're a liquid solution. The vanadium in these batteries is 100% reusable, so they're 100% recyclable in terms of metal content. More importantly, they have scalable capacity. Currently, there are plants being constructed with 800 megawatt hour peak storage in Dalian in China, 200 megawatt hours in Hubei in China, and also various other smaller scale, but still quite significant, storage capacities in Japan being currently constructed. So this is a technology that is currently being adopted and put into use. It has flexibility. It allows full capture of the full value of the energy storage in the grid and being able to turn it on and off as needed. It has a very fast response time, so it also has emergency applications with vanadium redox flow batteries. They can be used as an uninterruptible power supply in terms of emergency use. And also, there's no cross-contamination. The only element in the system is vanadium. So you don't get cross-contamination of other elements in there as well. So that's also a very important consideration in terms of the battery life and the battery reusability. When we look at cost competitiveness at the current price of vanadium in the current market as it stands at the moment, you see that they have significant advantages over lithium-ion batteries, even in the cost market and the structure as it is at the present time. Across the board. So in terms of the peak of replacement and peak load spreading, 26% cost saving. Distribution, if you want to store your battery and be able to store your energy and be able to put it into the grid later on, 32%, or into store your energy and then build your network and then plug it into the network. Also microgrids, places that traditionally have relied on coal or diesel power because they're isolated grid systems with one generator. Very significant cost savings relative to lithium ion. So how does this talk into vanadium demand? Well, the assumptions that have gone into this graph are most of the projects in the pipeline at the present time for vanadium around the world, if they come online. That talks into this blue line here. Also the restart of currently mothballed operations or operations that are on care and maintenance feeds into the blue line here. The green line is if we have 25% of the energy storage required to meet that renewable energy market of 2050 of the majority of energy around the world coming from renewable sources, is the green line. So that's the demand. The orange bars are the deficit between the production and the demand. So by the time we get out to even 2027, before we head out into the rest of that graph earlier that goes out to 2050 in terms of renewable energy, a lot of industry analysts are predicting a significant deficit at the current point in time from the markets from the projects that are currently in the pipeline globally between what's going to be needed and what's going to be able to be produced in the short term. So how do we meet that demand? Well, it comes back to the deposit styles. The vanadium, titanium, magnetite deposits are still the king when it comes to the deposit style out there because they're easily understood, they're a proven technology for recovery, and there are still significant global resources out there globally, including here in Australia. Deposits such as Windamara, Speewah Dome, these sorts of deposits do have significant vanadium resources and they will be future supplies into that market if these demand projections are borne out. Fossil fuels, well, we see that the fossil fuels in the energy markets are actually going to be phasing out in terms of relative production. And so that'll actually feed into the demand side. So we'll have less vanadium available in the market from the processing of fossil fuels. Another potential player out there is shale-hosted vanadium deposits. These also have significant resources and they also have comparable grades to the traditional magmatic minerals, vanadium, titanium, magnetite deposits. At the moment, they're not yet proven technology. There's not yet a demonstrated commercial scalable process put in play. But there are a number of companies out there that are actively researching this space at the moment, and there are some deposits out there that are going into production within the next several years based on these shale-hosted vanadium deposits, and that could potentially be disruptive technology when it comes into the supply and demand equation. If these deposits do prove to be economically viable, then there'll be an alternative out there to the iron, titanium, magnetite, low-grade deposits. So in terms of meeting demand, where do we go and look? Well, the first thing we need to know is that not all resources become reserves. So even though we have significant numbers of these deposits around the world, the blue being the iron, titanium, vanadium, the greens being the shale-hosted or sedimentary hosted style vanadium deposits, a significant number of these deposits still have a few, let's say, issues that need to be resolved before they can come into production. But if the demand equation demands that we need more vanadium, then a lot of these areas are going to be hot exploration plays coming into the future. And thank you.